Alright guys, this video is about Bronsted-Lowry acid and base theory. We're going to review how we identify the Bronsted acid and base and how we identify the conjugate acid and base pair. First thing is how we define the Bronsted acid and the base. Bronsted acid is something that can donate proton, so it has to have hydrogen in its formula. Bronsted base is something that can accept proton. In order to do that, it has to have at least one lone pair in its formula, okay, in its structure. Now let's just take a look at this picture. This picture is a general equation for us to identify the Bronsted acid and base. Okay. Now let's take a look at the HA. HA has one proton, so it can donate this one proton, and then it becomes A minus. Okay. So since HA can donate one proton, so it's a proton donor, it's an acid. For B, it can accept one proton donated by the HA, so it's a proton acceptor, so it's a base. Alright, so this is how we identify the Bronsted acid and base. Now what is a conjugate acid and base pair? Take a look at these two formula, HA and A minus. The only difference between these two formulas is just one proton. Okay, they are related to each other. So we assign these two HA and A minus as a pair. Now what does that conjugate acid and base mean? HA is an acid. After it loses one proton to become A minus, it has potential to accept one proton, so it becomes a base. And so we assign them. We assign the HA and A minus as a pair. On the other hand, after B accepts one proton, it becomes BH plus. And again, the only difference between these two formulas is just one proton. After base accepts one proton to become BH plus, it has potential to donate this proton to A minus, so BH plus can act as a proton donor. Okay, so we assign the B and the BH plus as a pair. In summary, Bronsted acid will become Bronsted base after it donates one proton, and Bronsted base will become Bronsted acid after it accepts one proton. Again, let's remember this. The only difference between conjugate acid and base pair is just one proton, so you need to check formula. Let's take a look at this first reaction. HSO3 minus react with water, generate the hydronium cation and the SO3 2 minus. Now when you compare the formula, okay, this formula and this formula, you can see that the only difference between these two is just one proton. So these two are a pair, a conjugate acid and base pair. And water and hydronium, the only difference is just one proton. So these two are a pair. Now how do we identify the acid and the base? On the reactant side, when you look at this, since HSO3 minus lose one proton to become SO3 2 minus, so it's a proton donor, so it's an acid. Water, it accepts the proton donated by the HSO3 minus to become hydronium, H3O plus. So it's a proton acceptor, so it's a base. Alright. Now what will happen on the product side? After this HSO3 minus donate one proton, it becomes the conjugated base or Bronsted base. Okay, so we can label the SO3 2 minus as a base because it has a potential to accept the proton from hydronium to make this reverse reaction happen. On the other hand, hydronium is from water. When water molecules accept one proton from the acid, so the hydronium has the potential to donate one proton to this SO3 2 minus to act as an acid. Okay, so this is how we identify the Bronsted acid and base, and how we identify the conjugate acid and base pair. Let's take a look at one more example. You have this this reaction here. Now, no matter how long the formula is, you just need to compare the formula before and after the reaction. Before reaction, it has 2 protons on one side and 7 protons on the other side. Now, apparently, this formula is very close to this formula, right? So you just need to compare. Apparently, this formula has 1 more proton than this one here. So it looks like this should be a pair. Water before the reaction, or on the reactant side H2O, on the product side OH. Again, the only difference is 1 proton, so water and hydroxide is a pair. Now let's identify the acid and base. On the reactant side, because this one accepts 1 proton, right? So it's a proton acceptor, it's a base. After it accepts 1 proton, it becomes a conjugate acid. For water, because it donates 1 proton to this H2C6O5H7 minus, so it's an acid. Again, after it loses 1 proton, it becomes the conjugate base, because hydroxide has the potential to accept the proton from this formula to make this reverse reaction happen. All right, this is how we identify the Bronsted acid and base, and how we identify the conjugated acid and base pair. Let me know if you have any questions.